expressions, excuse me, and equivalent expressions are just when both sides of an equal sign are equal to each other, when they are the same thing, okay? So when one side of an equation is equal to the other side of an equation, you have what are called equivalent expressions. That's what we're looking for in math. Life is good when things equal. When they're not equal, something's off, okay? So that's what we're shooting for in general in math. So I have all these properties, and if you'll notice, there are properties of addition, and there are properties of multiplication. Now, I didn't write out the word, I just put a symbol. You are welcome to do the same when I ask you what property it is, okay? So just know that when you see a plus, it's saying addition. And when you see a times, it's saying multiplication, okay? But you may just put a plus sign or a times sign every time. Okay, so the commutative property of addition versus the commutative property of multiplication. With addition, it says that A plus B equals B plus A, okay? I always tell people, think of it like your commute, okay? You commute to school, or your parents commute to work. So think of it as I go from home to school, and then I go from school to home. Did the distance of your commute change? No, they equal each other. So in other words, when you're adding things, you can say A plus B, and it's the same as if you say B plus A. You're allowed to flip-flop where they are, and they are equal, okay? So could you give me an example with numbers of where that would work? Pick any numbers for A and B and set it up in that situation. I'll do the first one so you know what I'm looking for. So for instance, I could say 7 plus 2, and it would equal 2 plus 7, right? 9 equals 9. So that's the commutative property. You may switch the order, and it still works. Damon, will you pull the notes up and fill this in with me? All right, so that's commutative property of addition. Commutative property of multiplication works the same way, but now instead of adding, we're multiplying, okay? So commutative property of multiplication says A times B will equal B times A. Can someone give me an example of that with numbers? Yeah, Avery. Yep, 1 times 2 is 2. 2 times 1 is 2. So it doesn't matter the order you multiply them in, you will still get the same value, okay? So that's commutative property. You go to school, you come home from school, it's the same distance. Associative property, again, there's an associative property of addition and there's an associative property of multiplication. They work the same way. And the associative property is a whole lot of moving parentheses around. So I'm going to tell you this, but don't hold it against me. Don't use it against me, okay? I am not a swearer. I do not swear in life in general, but I find that students remember it when they see it this way. So the associative property, if you notice, there are parentheses there, right? The parentheses are just moving to a new location. Have you ever made a but out of parentheses before? Right? It's like butt cheeks, okay? It's the ASS property, like a donkey. It's a bad word. It's another name for your butt, okay? So think that is parentheses, okay? I know it's silly. I know it's a little inappropriate. I'm not going to say the word because I don't swear, I promise. But for some reason, people remember it when their teacher's talking about butts. So parentheses go with the associative property, okay? What's happening is A plus B plus C is the same as A plus B plus C. So you can add in a different order and still get the same value, okay? An example would be if I do 2 plus 3 plus 4, I get the same thing if I do 2, plus, hold on. parentheses 3 plus 4. So in other words, I can say 5 plus 4 is 9, or I can say 7 plus 2 is 9. Okay, you're just doing it in a different order. If you follow the rules of PEMDAS, you would do the parentheses first. Okay, it doesn't matter which side you do, you will still get 9. Okay, so that's the associative property of addition. Associative property of multiplication works the same way, but now we're just multiplying instead. And the order in which you multiply them does not matter. Okay, so if we do this with multiplication, you could do something like 3 times 5 times 2 will equal 3 times 5 times 2, right? This is saying 15 times 2. This is saying 3 times 10. What's 15 times 2? 30. What's 3 times 10? 30. So even though the parentheses are in a new place, you get the same value. Okay? So that is associative property of addition and associative property of multiplication. Identity properties. For this one, I always say, so this is the property of addition, this is the property of multiplication, but it's the same idea. This one looks different for addition and multiplication though, because you're doing something different. So what I always tell people about the identity property is think of, I want to go back to a pen, sorry. Me or a mirror. Okay, my identity, who I am, does not change if I add nothing to me. Okay, so I am A, add 0 to me, what's my identity? Still A. Okay, I'm Brooke, add nothing to me, I'm still Brooke. Okay, the identity property, who you are. So that goes for addition with numbers as well. If I take 2 and I add 0 to it, I'm going to get that 2 back. Okay? But with multiplication, it's a little different because if you multiply by 0, what happens to a number?
0.
Its identity changes, it becomes 0, right? So with the identity property of multiplication, you multiply by 1, whereas with addition, you add 0. So if I say 6 times 1, I get that 6 back. If I start as a 6 and I multiply by 1, I'm still a 6. My identity, who I am. Okay, and then these last two are two just unique ones by themselves. There's not a property of addition and multiplication. So the first one is the 0 property of multiplication. And that's the one we just said. If you multiply something by 0, you will always get 0. Okay? So if I take the number 7 and I multiply it by 0, I'm going to get 0 back. If I take 1 million and I multiply it by 0, I get 0. Okay? And then the last one is the multiplication property of -1. And that just says if you multiply something by -1, you get the opposite of whatever you had. So if I have -1 times 6, what do I get? -6. What if I have -1 times -3? What do I get? +3. Okay, so it's the opposite of what you started with. So those are the different properties you're going to be using right now. And we're just going to walk through a few problems and see if they click. All right, so the first one, example 1, it says, what property is illustrated by each statement? So if you look at your chart, and you may look at the chart as we do this, that's totally fine. What is 42 times 0 equals 0? Which property is that? It is the 0 property. So remember, if you get 0, think that's my property, the 0 property. So it's the 0 property of multiplication. If I multiply by 0, I get 0. Okay? How about B? Z plus 13 plus 5 versus Z plus parentheses 13 plus 5. Which one is that? Associative property of what? of addition, right? We're adding. So it's the associative property of addition. All right, C, we started at 3A. We added 0 to it, and it stayed 3A. Which property? Identity. The identity of that 3A did not change. It was still 3A when we were done with the problem. So it's identity of what? Identity property, and you may just write prop, that's fine, of addition, and a plus sign is fine as well. How about D? 6x times 1 equals 6x. That's identity of multiplication instead. So this is the identity property of multiplication. Okay, so that's just a few of them. There are plenty more properties that we learned. You should be able to identify all of them, and you'll see them in the homework. So just see if you can figure that out. Okay, so the reason we learn these properties is it really does help in the real world. I have a real world problem for you, and I'll show you how, like, I feel like a lot of times people look at a problem and their neighbor answers it in like 2 seconds, and they're like, man, I was still trying to add the first two together. How did they do that so fast? I'm gonna show you how they did it so fast, okay? Here it is. It says a movie ticket costs $7.75, a drink costs $2.40, and popcorn costs $1.25. What is the total cost for a ticket, a drink, and popcorn? So basically our problem is $7.75 plus $2.40 plus $1.25. Okay? Now, right now, we could just add those together. But if you're trying to do it in your head, it's not the easiest to add $7.75 and $2.40. So instead, what we're going to do is we're going to use some of those properties we learned to make it a simpler problem. Okay? There are two numbers here that are for sure the easiest to add together. Do you know which two they are? 775 and 125, because 3/4 and 1/4 make $1, right? Gives you a nice round number. So in order to add those two together, what we're going to do is we're going to move some things around. So I'm first going to take these two and I'm going to switch places. So I'm going to make it 240 plus 775 plus 125. Okay? Which property did that for us? That said we're just going to flip-flop those two numbers. You go to school, you come home from school. Which property? Or your parents? Commutative property of addition, okay? So that's the commutative property. I'm just going to write it here so you know what we're doing. So it's commutative of addition, okay? Now to make sure that we don't just add these two together, we're going to put our parentheses in a different spot. So right now we would be adding those. Instead, why don't we do this? 240 plus 775 plus 125. Which property is that that says my parentheses were here, I'm just going to move them to here? Parentheses, make a but. Associative property, right? So it's the associative property of addition that we would be doing there. And now from there, we just have to simplify it. So 775 plus 125, can you do that in your head? Is 9, right? 7 plus 8, or 7 plus 1 is 8. 75 cents plus a quarter is $1. So 8 plus that $1 is $9. So we have 240 plus $9. What's 240 plus $9? $11.40. Okay? A much easier problem than trying to add these in the order they were given. So do that. When you see three numbers, think which two of these are the easiest to add together and start there. Then you can add the third one. That might be a little more difficult. Okay? Questions on that? All right. The third example, which is the back side of the paper, depending on how you uploaded it. I don't know if you need to flip to a new page or not. These ones, we're going to talk through what properties we use to simplify it. So there's still variables involved. You're not going to get just a number, but we can simplify here, okay? So if I have right now 5 parentheses 3n, what can actually be multiplied here? What two things? The 3 and the... But 3n is just going to be 3n. The 3 and the 5 can be simplified, right? So what we're going to do is take that. I'm going to make this a little bigger so it fits a little better. And we're going to move our parentheses. Instead of 3 times n and then times 5, we're going to do 5 times 3 times n. Which property does that? Where you can move the parentheses when you're multiplying. Associative property of multiplication. Okay, so that's the associative property of multiplication. So let's simplify. What's 5 times 3? 15 times n. And we say our reason for that is just we simplified. Okay, and we're done. Look at b. 4 plus 7b plus 8. What can actually be added together there? The 4 and the 8. So we need to get 4 and 8 together, okay? So the first thing I'm going to do is flip-flop these. I'm going to make this 7b plus 4 instead of 4 plus 7b. Which property takes them and flips where they are? You go to school, you come home from school. Commutative property of addition. Okay. What can we do next so that we can actually add our 4 and our 8? Move what? Move the parentheses. So I'm going to do 7b plus 4 plus 8. And now PEMDAS says I can actually add those. When you move parentheses, that's the associative property of what? This one's addition. Okay. Now, from there, if we actually do PEMDAS, we're going to add what's in there. So 7b plus 12. And we just say we simplified because we added what was there. Can I add 7b and 12? Can I make that 19b? We cannot. Do anyone know why? Because what? No, we don't want to annoy. We don't know what b is, right? So I can't just add them together, because if b is 2 versus if b is 7, you're going to get a different answer, right? So because we don't know b, because we don't have like terms, right? 7b plus 12 just stays as 7b plus 12. If it was 7b plus 12b, then they're like terms. Then we can add them together. Okay, but because one has a b and one doesn't, you may not add them. It's breaking the rules. Okay? All right. C, last one of these. This one's a little tricky in terms of how we break this down. But does anyone see something you can do here? Maybe you don't know this rule. The two y's, okay? We can simplify the two y's. So we can think of it like 6x over 1 and y over y, okay? What is y divided by y? 1, right? 7 divided by 7 is 1. Y divided by y is 1. Anything divided by itself, 1. So you're doing 6x times 1, and that equals what? 6x. So when you multiply something by 1, which property is that if you get the same thing back? I started as 6x, and I did not change. It's who I am, my identity. So that's identity property of multiplication. Okay? Questions on that? Okay, we're almost there. Very briefly, we're going to talk about what is a counterexample. A counterexample is just an example that shows something is false. So I give you an example and I say, okay, but it doesn't work in this situation. That's a counterexample. Okay? So we're going to say, is this true or false? And if it's false, give me a counterexample. Give me the reason we know it's false. So for the first one, for real numbers A and B, so any numbers A and B, is it true that A times B equals A plus B?
No.
Why not? Give me an example.
Because multiplication and division are not the same.
Right, but give me like actual numbers that prove it's false. So what is A going to be? 8. Okay, so if A is 8, what's B going to be?
5.
Is 8 times 5 the same as 8 plus 5? No, because 40 does not equal 13, right? So this is a counterexample, a situation where it does not work to show that it actually is false. Okay? All right, how about this one? For real numbers A, B, and C, is it true that A plus B plus C will equal B plus A plus C?
Yeah. Yes.
It is, right? They did the commutative property and they did the associative property, but it's still those three added together. So let's pick numbers. Let's say A is 3, B is 5, and C is 6, okay? We're saying 3 plus 5 plus 6 equals 5 plus 3 plus 6, okay? If we simplify that, they should equal each other. So 3 plus 5 is 8, plus 6, 5 plus 9. What's 8 plus 6? 14. What's 5 plus 9? 14. So it works out. That means this is true. Okay? The one thing I'd say is when you're looking for a counterexample, try not to use 1 or 0, because 1s and 0s are unique and they can throw things off, so it will look like they're true and they're actually not true. Use bigger numbers, okay, if you're looking for a counterexample. Alrighty? All right.